So the most important part out of all of these is domain and range for the most part. So for instance, sine, domain and range is negative infinity to positive infinity for the domain. Range is -1 to +1. For tangent, the domain is a period of pi between -pi/2 and pi/2. So if you just move it over again, it would be pi/2 to 3 pi/2 and so forth and so on. Cotangent, the range is infinite, but its domain is 0 to pi repetitively. So 0 to pi, pi to 2 pi, and so forth and so on. Now secant and cosecant. So if you have y equals cosecant of x, the first thing you do is you draw sine. 1, 2, 3, 4. Up, ooh. We'll say that's 1. Down -1. We'll say that's 2, just for fun. So when you draw cosecant, the first thing you start drawing is sine. So middle, high, middle, low, back to the middle. And don't draw it as a solid line graph. Draw it as a dotted line graph. Where the graph crosses the x-axis, you get vertical asymptotes, because when you reciprocate 0, you get 1 over 0, which is undefined. So you're going to have a vertical axis here, or asymptote, and another vertical asymptote over here, and a last one way over here. Of course, this goes on forever in all directions, well, left to right. So when you're graphing cosecant, it goes to the top of the crest, and it kind of looks like a parabola bounded between those two dotted lines. And the same thing happens at the bottom of the crest, and you go down. So graphing a cosecant, you graph the sine first, and then you just kind of flip it and look for those asymptotes at x-intercepts. So every time this graph hits the middle line, you're going to get a nice little vertical asymptote. And the same thing for secant. Same thing for secant. All right, so these are all the base graphs you have to know how to draw. Of course, then you throw in your period change and your phase shift and your amplitude change for sine and cosine, secant and cosecant. There is no amplitude for tangent and cotangent. When you set up the little tables, sine, cosine, cotangent, cosecant, and secant all start with 0. The only one that starts weird is tangent. It starts 0 in the middle. And you go left and right with your cuts. Tangent and sine, sine and cosine are cut into 4 pieces. Tangent and cotangent are cut into just 2. All right, so that was a quick review on graphing. What we're going to do today is much worse. Let me get rid of all of this. Well, I do have a ton of short videos on how to graph this stuff above the long lecture videos. 5-6 minute ones, I think they are. All right, today's topic is actually more important, strangely enough. Graphing them is great, but working with the math is much more interesting. So we're going to be talking about the inverse trig functions. This is 1.7 if I remember right. No. 2.7. Chapter 2. So anybody remember anything about inverse functions? Since we've done it before earlier this semester. What's a neat property about inverse functions? They're one-to-one functions. Obviously, not a single one of these functions is one-to-one. So we're going to have to talk about it a little strangely, but it'll still work. What else is good about inverse functions? Nothing? Why do we even have inverse functions then? If you have e to the x is equal to 7, how do you solve for x?
Take the alien and put it.
Why? Take a guess. Why? The word up there.
Inverse.
Because e and ln are inverses of one another. So when you ln, and the ln hits the e, what happens to the ln and e?
It's
They go poof and disappear. So if I have something that's like sine of x is equal to a half, and I want to be able to get rid of sine and actually get x by itself, the function that's going to help me do that is the inverse sine function. It's going to be labeled this way, and you're going to apply it to both sides to solve an equation. It's one possible way of doing it. But the problem is, sine itself is not a one-to-one function. So it's not a pure inverse. It's kind of like square root. If you take the square root of 9, what's its answer? 3. But underneath the square root, the answer should have been possibly -3. So that's why when you square root both sides of an equation, you have to tag in positive or negative. This is also not a perfect inverse function, squares and square roots. They're not perfect, but you still can use them slightly. So we're going to come up with a strange way of defining an inverse function. Seriously? So the first one we're going to start with is inverse sine function. Depending on what book you use, it could be this.
What do you mean depending on what book? Don't we all have the same book?
I'm saying if you ever see it in a different book and you see the words arc sine, it means exactly the same as this. If you find an older math book, you'll see arc sine. And if you ever see arc sine, it's just sine's inverse. The reason that arc sine was used is, as a typewriter, this is very easy to type in, where this is really very complicated because you've got to get that -1 up high. Either way you read it, this is the inverse sine function. Arc sine, sine inverse. Don't read it as sine to the -1, which is something totally different. So if I'm going to try to define a sine inverse, what is the main property of an inverse function? What does it do? Flips what? Got the right word. Now I just need you to tell me what. What's it flip? Nothing.
Flips the X.
And?
The Y.
Thank you.
Okay.
What's x usually called? When you talk about the x values of a function, what is that? Domain, and the y values? Range. So when we're inverting something, we're going to flip domain and range. So if I know the domain and range of the original function, I should be able to know what the domain and range of the inverse function is, because all you have to do is take them and flip them. All right. So let's look at the graph of sine again. The graph of sine looks like this. 1, 2. I'm going to do it backwards. So if this is pi over 2 and this is pi, if I go backwards, this is -pi over 2 and -pi. Up 1, down 1. Where does sine start? In the middle. Sine starts in the middle. The sine of 0 is 0. Then at pi over 2 it goes up. At pi it goes middle again. And on the right-hand side, you get this. On the left-hand side, what if I go backwards to -pi over 2? Where do we go? Go down. And then at -pi,
Middle.
back up. So this would be a period of sine, a very unusual period, -pi to +pi. There's a reason I'm doing this, not just for the fun of it. So, is this function invertible? What do you have to be invertible? We said it earlier. 1, 2, 1. What's a one-to-one function mean? What test does it pass? The horizontal line test. Vertical is for function, horizontal is for one-to-one function. Does it pass the horizontal line test? No, it fails it. Is there a portion of the graph that includes the entire range that could pass the one-to-one test? In other words, if I took some scissors and cut off some pieces that I don't want, what interval would I look at? so that it is 1 to 1 and includes the entire range. In other words, what's getting in the way of the horizontal line test?
The fact that it goes up and comes back down.
I know, so get rid of the it goes back down part, or it comes up.
Why?
Get rid of the y completely. As you're making this horizontal line test here, how many times does it hit the graph? 2, but it doesn't hit it over here on this far. So out of those 2 pieces, which one do you want to get rid of? Yes, it does. Because I want a continuous line from positive 1 to negative 1. I want that function to have that option of going
So
back.
you want to get rid of the left side.
Yeah, I want to get rid of this. So if we get rid of this, what else can we get rid of?
The top right side.
Top right side. Get rid of this part. Now, if I get rid of those 2 pieces, is what's left over 1 to 1?
Yes.
Yes. So if I just look at this part of the sine function from this point to this point, and not look at anything else, then I can make that a 1 to 1 function. Therefore, it must have a inverse. So if I redraw that really quickly, we're talking about just this little portion of the graph from pi over 2 to negative pi over 2. So if I just look at it this way, what's the domain? Negative pi over 2 to pi over 2. What's the range? Negative 1 to 1. So if this is sine of x, the way I'm defining it on a restricted domain, negative pi over 2 to positive pi over 2, how do I make it the sine inverse? Remember what changes. Take the domain and range and flip it. So whatever was x is now going to become y, whatever is y is now going to become x. So this coordinates, all these coordinates over here are going to switch around. So we're going to have 1 over here, negative 1 over here, pi over 2 up here, and negative pi over 2 down here. The x and y's are literally going to flip-flop. And then you just plot your coordinates. So this coordinate here used to be pi over 2 comma 1. When I flip-flop it for the inverse, it's going to become 1 pi over 2. 0, 0, which is kind of boring, stays the same. 0, 0. And then this one over here is negative pi over 2, negative 1. So we're going to get negative 1, negative pi over 2. Almost looks like a straight line, doesn't it? Except for one problem, it's not. It's got a little curve to it. And the way to do the curve is to imagine this. This sine curve would be wrapping around the x-axis. If I drew this inverse sine all the way, which wouldn't be a function, it would wrap around the y-axis. So basically what's happening is you're getting this shape. Ooh, did it wrong. And you can kind of imagine that's just wrapping around the y-axis. So this portion of the graph, along here, this is the inverse sine function. Its domain is negative 1 to 1. Its range is negative pi over 2 to positive pi over 2. You always go small large. Small large. Great, except for, slight problem. The sine inverse doesn't work on everything, and it doesn't always give you the right answer. And the reason is this. If I'm looking at the domain negative 1 to 1, is this well defined? Can I do that? Can I find that? What's 3 halves equal to? 1.5. So, if my domain is negative 1 to positive 1, can I find sine inverse of 3 halves? No. 3 halves is larger than 1. There's no way I can find it. Second thing you have to realize, when I write y equals sine inverse of x, what does the x and the y represent? It's a coordinate on a point, but what does it represent in terms of trigonometry? what do we take care of with trigonometry? Angles and the triangles give us some old hippie called another hippie tripping on acid. Old hippie is opposite over hypotenuse. What do we call things like opposite over hypotenuse? What kind of number is that?
Fraction.
And fractions are also known with R.
Ratio.
Ratio. So out of these two, the x or the y is a ratio. Which one? Well, let me write it the other way. If I write y equals sine of x, out of these two, which one's the ratio?
What?
The sine of a equals a. I talked about this before. Brain's leaking out already. What do you take the sine of?
A number.
What kind of number? What does it have to be? When you're in a triangle, and I say, I want to solve for this side over here. What do I need to know? What do I need to know? I need one more side, and say this is 7, and sure, if you're going to Pythagorean theorem, but that's not trigonometry. What else do I need for trigonometry? The angle. I need an angle, this one or this one. Doesn't matter. So, sine of a.
Angle.
Thank you.
You're stressing me out.
But if you think of it as a number, when I ask you to do sine inverse, you're going to screw it all up. So you got to know which one's which. So x is an angle here, y is a ratio. It's like
y is the
0.2.
ratio and x is the angle.
Up here, x is a.
Y is the angle and x is the ratio.
Thank you. X is an angle, or y is an angle, and x is a ratio. This and this, you have to be very clear about now. You can't just start throwing numbers into things and hoping to God it works out. Because it's not going to work. If you put them in the wrong place, you're going to get some crazy answer. That usually doesn't make sense, and usually your Kepler is going to sit there and go, domain error, or something silly like that. So when you're dealing with sine inverse, you have to put a ratio inside of it, and it spits out, oh, that's horrible, an angle. This doesn't erase very well.
Yeah, that's pretty crappy.
Yeah, that is pretty crappy. Ah, these markers. I'll have to stick with green to erase as well. Alright. So, if I ask you to find the sine inverse of 1/2, what am I asking you to find?
The angle.
The angle. That's all you care about. This is going to equal an angle. Let's call it theta. So, if you have sine inverse of 1/2 is equal to theta, kind of like logarithms and exponentials, you could rewrite it any which way you want. So how can I write it so it's something of an angle is equal to the ratio?
The sine of theta is
Sine
equal to
of
1/2.
theta.
So this is the same thing as the sine of theta is equal to 1/2.
Yeah.
Okay. So how do I find out when the sine of theta is equal to 1/2?
So
Draw a
what?
picture. Not necessarily a triangle, but a picture. What kind of picture? A coordinate plane.
Yay.
Remember, this is what we spent all last class doing. For a reason. I knew this was coming up. Oy. So, sine of theta is equal to 1/2. Where would I draw it?
Either in the first or second.
Either the first quadrant or the second. All right. So I'm going to put an angle in the first and an angle in the second. Now you have to think for a second. The angle in the first is between 0 and pi over 2. The angle in the second is between pi over 2 and pi. Sine inverse is only going to spit angles out between negative pi over 2 and positive pi over 2. So what quadrant, what quadrant does it have to be in for sine inverse?
You can be second. It's first.
Negative pi over 2 to positive pi over 2. Where's negative pi over 2 from here? No, that's negative. That's pi.
The fourth quadrant.
Where's
Negative pi over 2?
where's negative pi over 2 precisely? If this is 0, what's the top green line? So where's negative pi over 2?
The bottom.
Bottom green line.
Yeah.
All right. So it goes from the bottom green line, negative pi over 2, past 0, all the way up to positive pi over 2. So sine inverse is only going to work in these two quadrants. It does not work anywhere else. It only works in the first and the fourth. So when you draw your triangle, can I draw the triangle in the second quadrant? No. So the only triangle you're going to get is this one. How do I label the sides if this is theta?
It's opposite over hypotenuse, so the opposite would be 1.
Opposite over hypotenuse, so the opposite side has to be 1. The hypotenuse is 2. What's the last side? Just for fun. Square root of 3. What does that angle have to be?
Or the 30.
It's a 30, 60, 90, I'll give you that.
It's the 31.
It's the 31. So theta is equal to pi over what? If it's 30 degrees.
Pi over 6.
Pi over 6. Today's just going to be pulling teeth day.
Yay.
Going back to the pictures and everything else. So, sine inverse only works in the first and the fourth quadrants, and you can't draw your pictures anywhere else. Okay. How about sine inverse of negative square roots of 3 over 2?
I don't like that one.
What is this going to equal eventually? Not specifically, what is it going to be?
Theta.
It's going to be an angle, theta. How can I rewrite it?
Is sine of theta is equal to the negative square root of 3 over 2.
Sine of theta is equal to negative square roots of 3 over 2. So if I was going to draw this as a picture, where would I draw it? When is the sine negative?
In the
Fourth quadrant
third.
and
the
the third. But remember, sine inverse only works first and
So it's
fourth.
So it's going to be the fourth.
It's got to be in the fourth quadrant.
Pass.
So you draw your triangle in the fourth quadrant, and you make sure it goes up to the x-axis. And you make sure it goes up to the x-axis. Not some weird pictures anymore.
Those triangles are pretty.
So this angle here is theta. How do I label my sides?
The opposite is negative. No, it's
Yeah.
negative square root of 3.
It's negative square root of 3, if you want to keep the sign with it. The hypotenuse is 2, the other side is?
1,
What's the measure of that angle?
60 degrees.
Better known as pi over?
3.
Now, is that the right answer?
Maybe.
I hope so.
Probably not.
Special triangles.
Oh, wait.
I heard you. Special triangles.
No, the correct answer is 5 or 6.
No,
What? Why?
it's pi over 3, but it's not the right answer.
It's negative.
It's
Negative
negative.
pi over
Why?
3.
Because it's going
It's in the, yeah.
clockwise. It's going clockwise, so it's negative pi over 3. Because you're in the fourth quadrant, but your answer has to go down. All right, so that's sine inverse. Works in the first and the fourth, nowhere else.
Possibly.
So what about cosine inverse? Switch this out. Oh, so thanks. There we go. All right, cosine inverse. If we look at the cosine function, oh, this one's not much better. If we look at cosine of x, and it goes up 1, and it goes down 1, and it starts to negative pi over 2, positive pi over 2, pi. Let's go up to 3 pi over 2.
You have a random line on your screen.
Yeah, it does that every once in a while.
when I put my top back on, it still makes a sound, and sometimes it catches it. I can't help that.
All right, so if I graph cosine, where does it start?
High.
0, 1, high. Then it goes middle, low, middle, and then high again if I drill it up to pi. If I go backwards, where does it go?
Middle.
Middle. So we get a graph that looks like this.
Okay.
So you wanna look at the middle part?
Is it a one-to-one function?
No. So if you were going to get rid of something, what would you get rid of?
Be top left and bottom right.
Top left, bottom right. So get rid of this piece, get rid of this piece, and work with what's in between 0 and pi. So the domain of this function would be 0 to pi. The range would be, that's the easy one. And when we invert it, all we have to do is take the domain and range and flip it. So if we look at cosine inverse,
That's a horrible marker.
yeah,
You can barely see it.
ooh, I actually have it a little bit off there. Let me undo.
Another horrible marker. Let's trick shot.
Hook shot.
Hook shot.
Slash.
Oh,
Oh,
it
yeah.
Double
That was
points for the
good.
bounce.
Bounce counts.
How did it bounce that high up?
I don't know. Physics, gotta love it. Alright, let's see if this one works better. Not much. Alright, so if we flip the coordinates around, the y-axis becomes the x-axis, so it becomes -1 to +1. What goes on the y-axis then, that I'm interested in?
Your y-axis is gonna be 0 to pi.
0 to pi, but also interested in pi over 2. So pi over 2, and up here, pi. Put our coordinates in. First coordinate.
Sorry.
0, 1. So that becomes
0,
1,
1, 0.
1, 0, which is over
Yeah.
here. The next coordinate is pi over 2, 0. So
0
that
pi over
becomes
2.
0 pi over 2. And the last one is
-1.
pi -1, so -1
Pi.
pi.
Yay.
And remember, the curvature is, as it comes across this point, it's kind of going that way.
Yep.
So we have to draw it kind of like that. The shape of it's not super important. The domain and range is. All right. So the domain of this thing is -1 to 1. So I can take any number I want between -1 and 1 and shove it into the cosine inverse. The range, though, is what kind of answers it spits out. What's the range?
0 to pi.
0 to pi. What quadrants is 0 to pi?
From the first layer
First quadrant
and second.
and second. So when we're doing cosine inverse, it only works in the top two, where sine inverse works on the right two, first and fourth. All right. Oh, that's horrible. I don't know what that did. So what about cosine inverse of 1 over the square root of 2?
It's the same thing as this.
What does 1 over square root of 2 represent? Angle?
Just a ratio.
The
Ratio.
ratio, right? So this thing is going to equal an angle. So I'm just going to call it theta. So if you rewrite this, it becomes cosine of theta is equal to 1 over square root of 2, which, by the way, is the same thing as square root of 2 over 2. In case they give it to you as square root of 2 over 2, trust me, you want to write it as 1 over square root of 2. Okay, so where is the cosine positive? First quadrant and
The fourth one.
the fourth.
It's gotta be the first.
But cosine inverse only works in the first and the second, so the angle has to be in the first. So you draw a triangle in the first quadrant, and this is theta. How do I label my sides?
It's gonna be adjacent.
Adjacent over hypotenuse.
So it's one
One where
bottom,
bottom.
and square root of 2 is the hypotenuse.
Square root of 2 is the hypotenuse. The other side is 1. So it's theta equal to. Better known as
Over 4.
pi over 4. That's it. Yeah, we're learning. It's not hard. What messes people up is which quadrant it goes in. That's the only thing that I think will mess you up. All right, how about cosine inverse of, let's think of a good one. Yeah, it doesn't even matter. Negative 1/2. So cosine inverse of negative 1/2. Set it equal to theta. It's an angle. Cosine of an angle gives you ratio. Cosine inverse of a ratio gives you an angle. All right, so rewrite it as cosine of
There you go.
theta is equal to
Negative.
1/2. Where is cosine negative?
In the second and third.
Second and third quadrant, but cosine inverse only works
First.
the top two, so it has to be in the second quadrant. So you draw a reference triangle in the second quadrant. Label this theta, even though it really isn't. It's technically the reference angle of theta. So that's just label it theta. How do I label my sides of my triangle?
It's adjacent over hypotenuse.
So again, it's adjacent over hypotenuse, so where's the negative one go?
The bottom.
Negative one goes to the bottom, 2 goes at the hypotenuse, the third side. Just for reference, is square root of 3. You don't even need to know it, but it's nice to have it in there. So what's this? Well, I'll call it theta sub r. What's theta sub r equal to? For reference.
60 degrees?
60 degrees, pi over 3. So this angle here is pi over 3. What's this angle up here equal to?
Obviously.
No,
I was close.
you're not even close.
Negative.
Negative would be going counterclockwise. This angle opens up clockwise.
Oh no. 2 pi over 3.
2 pi over 3.
Oh, Lord.
Because the angle is starting here and it opens up to here.
Yeah.
If this angle here is pi over 3, this one has to be
Yeah.
the other two pieces.
Yeah.
2 pi over 3. It's an obtuse angle. It's greater than pi over 2. Because you start at the positive x-axis and you have to open it up. So if it's pi over 3, the top gets cut into 3 pieces and you have to back off 1. That leaves you with 2. Oh, we'll do another one. That one's a tricky one.
Yeah.
Sine's easy. If you go backwards, it's negative. Cosine goes obtuse. How about cosine inverse of negative square root of 3 over 2? Is that equal to theta?
What?
Cosine inverse of negative square root of 3 over 2. What do you mean, what? What? So, what's its alternate form?
Cosine of theta equals negative square root of 3 over
All right. What quadrant does it have to be in?
2. Second and first.
Well, the inverse function is second and first. Where's this angle?
Let's do the second.
It's got to be in the second.
Yeah.
So you draw a reference triangle in the second quadrant.
Yeah.
Call this theta sub r. How do I label my sides?
Adjacent.
So the adjacent is negative square root of 3. The hypotenuse is 2. The third side is 1. What is the reference angle?
30 degrees.
So theta r is equal to pi over
6.
6. My answer is
5 pi over 6.
5 pi over 6 because
Gotcha.
you have to open up.
Gotcha, son.
It's like pulling teeth, I swear.
Hey.
And by the way, that's the easy part.
Oh, okay.
Here comes the hard part.
That was.
Mm.
But you notice that you keep drawing triangles, whether you're going forwards or backwards. So the best thing you can do is keep drawing pictures for every problem that you do. Just so you don't make silly mistakes. So how can I make it worse?
I'm sure you can find a way.
Oh no.
Wait, what?
Composition.
Oh no. A sine of what?
How you take negative
Inverse
Sine
sine
inverse.
of sine.
Sine inverse of sine of pi over 3. It actually doesn't even matter what the angle is, but I can at least calculate this one out to show you what's going on. So if you're going to actually calculate this out, you start with the sine of pi over 3. What's the sine of pi over 3 equal to?
60 degrees.
That's 60 degrees. So if you drew your triangle, here's 30, here's 60. This is 1, 2, square root of 3. So what's the sine of 60?
the sine of 60. It's square root of 3 over 2.
So this becomes the sine inverse of the square root of 3 over 2. I highly suggest you don't do it this way, but I wanted to show you how it flows normally. All right, then what do you do?
Then why are you doing this?
Because if I do it the other way, no one gets it at all.
But if you
But if I show you
just
piece
do
by
it
piece
this
what's
way,
going on, then when I do the shortcut, it comes out a little bit nicer. Then what do I do? Coordinate plane. When is the sign positive? You don't even have to switch it over if you don't want to, but when is the sign positive? 1 and 2, but sine inverse only works in?
The first and fourth.
So where does this one have to be?
1.
1, so you go here. You would label the angle square root of 3 over 2. What's the measure of this angle have to be? Opposite over hypotenuse, that's a 1. So what's that angle have to be?
60 degrees.
Better known as pi over
3.
pi over 3. So,
but it wasn't pi over 3 to begin with.
right. So if I have sine inverse on top of sine, they
They
seem to
cancel each
go
other out.
poof, and they end
Yeah.
up with pi over 3. Okay.
Is it funny how I somehow knew that, but I didn't say that?
Yeah,
You should have said something.
I was thinking that. It's like, wait a second.
Like when I saw the inverse of sine of the sine, I was like, they just go away.
So,
Oh, wait a minute.
so the only reason why we don't have to, like in cosine is because it's already going counterclockwise, so that's why we do you use the reference angle then to find the other one, right? Because sine is going counterclockwise.
Yeah, sine only goes between positive pi over 2, negative pi over 2, so it's always acute. It's always an acute measurement, just positive and or negative.
Oh.
Where cosine could be acute or
Obtuse.
obtuse, and that's where it gets a little funny.
Oh.
Or
But-
that works.
But this even gets worse.
What is, can you do cosine inverse of a sine?
Yes,
Oh,
well,
no.
we'll get there. How about sine inverse of sine of 7 pi over 6? Do you think the answer is 7 pi over 6?
No.
No, it's not.
No, it is not. It can't be. Why?
Pi over 6. Right? Yes.
But yes, maybe. Yes, maybe.
It's
But
not pi over
can it
six.
be 7 pi over 6?
No.
Why?
Because it can't be
Because
in,
it didn't do it all.
it can't be in the third quadrant.
Cannot be in the third quadrant because sine inverse only works in the first and
Second.
So
the
it's negative pi over 6.
Fourth.
fourth. So is it negative pi over 6 or is it positive pi over 6?
It's negative.
Are you sure?
No.
Yes.
Yeah.
Well, let's find out.
Maybe.
If we drew 7 pi over 6, what quadrant would it land in?
Third quadrant.
It would be the third quadrant, so you'd have this angle down here for 7 pi over 6. In the third quadrant, sine is negative. So what you have to do is you have to find the right quadrant that sine inverse actually works in that is still negative. What quadrant would that be?
Fourth.
Fourth. So what you have to do is you have to reference your angle into the fourth quadrant. What is the measure of that angle?
Negative pi over
Negative pi over 6. So the answer here is?
6. Negative pi over 6.
Did I not say that?
Yeah, I just wanted to show you
Okay.
all the reasoning
Yeah.
behind it. So up here, the sine inverse and the sine seem to just go poof. And they will as long as the angle's in the first quadrant. But once it leaves the first quadrant, you have to slow down and actually go and do some work, or at least some thinking, to figure out what's going on. So how about cosine inverse of cosine of
Sine.
2 pi over 3?
That'll be 2 pi over 3.
You sure?
Cosine works in
First and
first and
second. So where's 2 pi over 3?
and second quadrant.
Second quadrant. And
So-
cosine inverse works first and second. So what happens with cosine inverse and cosine?
Poof.
They go poof. So this becomes 2 pi over 3. So if the angle lands in the right quadrant, they go poof. If it lands out of quadrant, you have some work to do.
Yeah.
All right, what about cosine inverse of cosine of 5 pi over 4?
Do we have to do work for this one?
Yeah. It's out of quadrant. Where's 5 pi over 4?
In the third.
Third quadrant.
It's in the third quadrant down here. So this is 5 pi over 4. But cosine doesn't work in the third quadrant. So you have to ask yourself, all students take calculus. Is it positive or negative?
It's gonna be a negative.
It's going to be a negative. Where is the cosine inverse going to spit out negative answers or take negative answers?
You go the opposite.
In the second quadrant. So what you have to do is you draw your angle in the second quadrant. What is the measure of this angle going to be?
45.
Pi over 4. What's the answer?
5 over
So the chase.
Sure, if it was in the first quadrant.
4.
It's in the second quadrant.
Negative.
3 pi over
3 pi over 4.
Great.
So this is equal to
3 pi over 4.
3 pi over 4. So you have to be really, really cautious. Where are you? Where you need to be.
Bam.
Does that make sense? You look
No.
inquisitive. Cosine inverse only works in the first and the second.
Okay.
Okay.
Cosine in the third quadrant is negative.
Okay.
You have to pick the other quadrant. It happens to be negative out of 1 and 2.
Mhm.
1, it's positive.
Mhm.
So 2, it must be negative.
Negative.
If you,
So
I
you
got that
put
part.
the angle has to go in the second quadrant.
if you take the graph on the right and flip it upside down, you get the graph on the left.
Yeah, basically.
I know, but it 3.
So this reference angle here is pi over 4. Because it was pi over 4 down, so it's going to be pi over 4 up.
I get that part.
But you always measure angles starting at the positive x-axis.
Mhm.
So if I measure this angle, what is it?
3 pi over 4.
If it's pi over 4 here, that means it's 4 pieces in the top. Back off 1.
Oh, okay. Never mind.
3 pi over 4.
Okay.
Okay. Okay. All right, so what about sine inverse of cosine of 2 pi over 3?
Oh, have mercy, Jesus.
You asked if you could combine them, so I figured I'd combine them.
No,
Sine inverse of cosine of 2 pi over 3. What should you do first?
Cosine of 2.
Nope. Where the heck is
2 over.
where the heck is 2 pi over 3?
In the second quadrant. Second quadrant.
Second quadrant. Great. But we're working with sine inverse here. In the second quadrant, what is sine?
Negative.
Positive.
Positive, all students.
Yeah.
So it's positive in this quadrant. So where else is it positive out of the 2 quadrants that sine inverse actually works in?
The first one.
The first one. So if I throw this angle in the first one, the reference angle never changes. The reference angle over here was pi over 3. So the reference angle over here is also going to be,
Pi over
so my answer here is,
3. Pi over 3.
because it's in the first quadrant.
Flat down.
Oh, okay.
That's all. It's not that bad.
Boom, boom.
Pulling the teeth. Cosine inverse, sine inverse first is perfectly fine, but what if we flipped it? So I write cosine of sine inverse of something. What has to go in the something?
It's
Angle or ratio?
Ratio.
Ratio.
Pi.
Because it's inside of sine inverse. And sine inverse takes ratios and spits back angles. So I have to put a ratio in here. Can I put in 5/3? Why? Because it's bigger than 1. So I have to be really careful here. 5/7. Has to be smaller than 1. Absolutely smaller than 1.
So how am I going to find the cosine of sine inverse of 5/7?
Well,
You draw a picture.
What quadrant?
One of the four.
Okay, what quadrant?
third quadrant.
Ah, dang it, what quadrant?
It's the first one.
The first one.
What?
Oh.
5/7 is positive.
Yeah.
Sine inverse only works in the first or the fourth. But in the fourth quadrant, sine is
Negative.
negative, so it has to be in the first.
Yep.
So, first quadrant angle, draw a triangle. Call this theta. Why not? It's not going to hurt you. How do I label the sides? Opposite over hypotenuse. So the opposite side is
It's 5.
5. The hypotenuse is?
7.
How do you find the third side?
Isn't it 6?
No. It would be nice 5, 6, 7.
Yeah.
But there's only one triangle that does that. 3, 4, 5.
Yeah.
That's the only one.
Really?
No, then 5, 12, 13, 8, 15, 17.
Is it square root of 6?
No.
What's the third side? How do you find it?
Pythagorean.
So c squared equals a squared plus 9 squared. 7 has to go in the hypotenuse, so this would be 49. 25 plus
Square root
2 squared. Subtract that across and you get 40. No,
It's 2 square root of 3.
40.
Whoa.
24.
Oh,
So you get b squared is equal to 24, therefore b is equal to
2 square root of 3.
close no cigar.
Was that really?
Yeah.
It's 2 square root of 6.
2 squared is 6. It's 4 times 6. So it's
I had the
4.
6 part right.
You said 3.
Oh, like earlier when I said 6, and then I said square root of 6.
Oh.
Wait, what?
So this side is 2 square roots of 6. So what's the answer to my problem? The cosine of the sine inverse of 5/7. Well, we took care of the sine inverse of 5/7. Sine inverse of 5/7 is right here. It's that angle. Do we care what the measure of that angle is? No, I care less about it because I'm looking for the cosine of that angle. So what's the cosine of that angle?
It's 2 square root of 6 over 7.
Adjacent over hypotenuse.
And that's it?
That's it.
Wham bam.
Very simple.
Make sure you cut that part out.
Wham bam.
Never. Never.
All right, how about sine, cosine inverse of negative 8
9.
17ths.
Why?
There's a reason.
Isn't it going to be 15?
I think, if I remember right. So, what do I do first?
Ow.
Draw a picture.
Draw a picture.
Yay.
What quadrant?
Second.
Second, because cosine inverse only works in the first and the,
Second.
and the only place cosine is negative is
Second.
second. So you draw a triangle in the second quadrant.
Yep.
Call this theta, even though it's just a reference angle.
Yep.
All right, how do I label my sides?
So now you have to find the sine.
Cosine is adjacent over,
So
Hypotenuse.
bottom.
so negative 8 at the bottom, it's going to the left. So you guys
17
make
is
it-
your hypotenuse.
17 is the hypotenuse. The third side is?
15.
You sure?
Yes.
Have you worked it out?
No, you told us earlier.
Don't remember if it's right.
You're
So
like
17
8, 15,
squared
17.
equals 8 squared plus b squared. What's 17 squared?
I'm about to find out.
Too much.
269? No. 289.
289.
289. So this is 289 equals 64 plus b squared.
Minus 64.
What's 289 minus 64?
It is 15.
225.
It's 15.
And it is 15. So b is equal to a nice 15. So this side is positive 15 or negative 15?
Positive 50.
Because it's going
Up.
up. Right. So what's my final answer?
Negative the sine, right?
15 over 7. Opposite over hypotenuse. See, everything goes back to those triangles and some old hippie and all that other junk.
Mm-hmm.
And all we do is keep drawing the same pictures over and over and over again.
Double jump. Insane.
Last one.
Yay, last one.
Well, how much time?
Yes, last one. Last one. You said
Last
it.
one.
You said it. It's 225. You said it. Last one.
Last one you heard it, camera.
It's on the microphone.
Delete that part.
No, you don't.
This! I have to delete it now. That's even worse. Ah.
It's better than what I really wanna say.
Oh, there's a problem. I haven't done tan inverse. I do have to teach that, but it's not much different than sine and
They go
cosine.
into it. Right
It's
now.
actually kind of easy.
Just do that one right now.
Tan inverse?
Yes.
Sure. Yeah, do that.
Fine. Tan inverse of x. What's the graph of tan of x look like?
I don't
A lie.
You don't remember?
big graph.
I drew him wrote it.
It's got a
asymptotes.
vertical asymptotes.
Where?
Add a negative pi over 2 and pi over 2.
Negative pi over 2 and pi over 2.
I guess.
That's a good guess. Vertical
Way to get
asymptotes, negative pi over 2,
Way to go.
pi over 2. What's the graph look like between those vertical asymptotes?
S graph.
Where does it cross?
At the
0.
At origin.
Yeah.
To the right it goes,
Up.
to the left it goes,
Down.
down. Domain?
Step on up right one.
Oh, by the way,
Do I? Oh,
I haven't said anything because I was
Domain?
waiting for y'all to shut up.
domain is negative pi to, negative pi
Before I
to
go
pi.
domain, is it a one-to-one function the way I've drawn it?
Yes.
Yeah.
That's the beauty of it. So, what's the domain? Negative pi over 2 to,
In parentheses.
in parentheses, that's an important part. It does not include negative pi over 2, it does not include pi over 2.
Yeah.
Glad you remembered that part. Range?
What are you talking
Negative infinity to infinity in brackets. Or
Negative?
in
Don't you
parentheses.
dare put those in
Whoops.
brackets. Infinity.
Look, I did get the first part.
Alright. So if I flip-flop this,
Thank you.
and I do the inverse function, so I'm talking about tan inverse. I'm not going to draw it. The range and the domain flip. The domain becomes negative infinity to positive infinity.
So it'll be going.
That means you could take the tan inverse of anything
Oh.
Oh.
because the domain is negative infinity to positive infinity. So you could take the tan inverse of 5/7, 7/5.
But it
Square
will
root
go
2.
up and down so high.
When you take the inverse, it flips it. It only goes up to pi over 2 and down to negative pi over 2.
Yeah, so it'll go on forever, but
Forever.
it'll only go up and down to a certain point.
It'll get close to pi over 2, but it'll never get there. So the range is negative pi over 2 to pi over 2.
Would those be asymptotes? The horizontal asymptotes?
Well, they would become horizontal asymptotes, yeah.
Okay.
So your angle that gets spit out is where? That's the important part. What angles are we spitting out of this thing? What quadrants?
It's gonna be the first and second.
First and fourth.
Yeah.
I meant that just like going sideways.
Yeah. So sine inverse and tan inverse are exactly the same in their quadrants. They're first and fourth. Cosine's the weird one. It's first and
Second.
second.
Third is just there.
And sine inverse and tan inverse always give you acute angles, where cosine could give you acute or, and that's that weird one, the obtuse one. Obtuse. So let me ask this question. While we're here, data page. For example, if I want to find the sine of tan inverse of pi over 6. Well, let's make it 5 pi over 6. No! Wait a minute, I'll leave that though. I'm gonna leave that until someone yells at me.
We obviously can't do it because you said no.
Why though?
Because you said so.
So tell me why.
In the
Because you
second
said
quadrant, you can't be in the second quadrant.
Nope, that's not why.
What?
Because it's positive and
No. There's something wrong with what I wrote up on the board. Absolutely horribly wrong.
it looks like you wrote
Yeah,
an N
both.
instead of an N.
Can you do the sine of tan?
I can take the sine of tan inverse.
It looks just as messed up as everything else.
No, this one is more messed up than everything else.
Wait, it's an angle and not a ratio.
Ah.
I
This is majorly wrong because this is an angle. What is supposed to be there?
A ratio.
A ratio.
Tisk to tisk.
Horrible on my part.
Yeah,
So,
John.
sine of tan inverse. See how easy it is to do though? Because they both look like fractions. But you have to be really clear. One's an angle and the other one is a ratio.
So if we're given a problem that says it gives an angle inside, we just write like undefined, we can't do it.
Right. Or Mr. Cloran, you're an idiot.
Yeah,
I'll
That'd
run
go
that one.
very well too.
I'd like to challenge this question.
Then you could do that.
But
I'm going to notify your superior that you have no clue what you are writing. That'll work too. So where do I start?
What upon?
What?
Draw a picture.
Draw a picture.
Questions
You
of
draw a
unemployment
picture,
line. Draw a picture. What quadrant?
It's gonna be in the first.
Going to be in the first, or
Yeah.
just in case, or
It could be in the fourth, but it's not.
no, it's not in the. Well, tan inverse is first and fourth, but positive tangent would be
First
where?
and third.
First and third, yeah, well, right across from each other. But this one has to go in the first, so you draw a triangle in the first. Can tangent take something bigger than 1?
Yeah.
Yeah.
Yeah, tan inverse can take something
That's
bigger
right,
than
it
1.
can.
It goes to negative infinity to positive infinity, so that's pretty safe. Tangent by itself is adjacent over, no, opposite over adjacent, tripping on acid. So opposite would be 13, adjacent would be 12. This is the angle that we're working with.
Pythagorean theorem.
You said regular tangent is opposite over adjacent, so wouldn't the inverse be the other way?
Inverse tangent goes from an angle to the ratio, or from the ratio to the angle. That's all it does. It doesn't reciprocate. Reciprocal of this would be cotangent. Yeah, don't get confused with that -1 there. So what's the third side?
Figure it out.
Go ahead. Why would I do it? I know what the
Pythagorean
answer is.
theorem. 12 squared plus 13 squared equals a very big
313.
number.
It is not 313.
No, when you add the squares together,
Oh.
square root of 313, it does not give you a big number, so you have to figure it out.
Really?
Yeah.
Square root of 313.
I'm quite sure it was a special triangle.
It's not. 12 squared is 54.
How about 13 squared?
Yeah, you get 313. You can't take the square root of that.
Darn it. What
So
was that thing? 5, 12, 13. Never mind. I put it in the wrong place. That's all right. So what's this one?
Square root of 313.
Square root of 313. Darn it.
Yeah.
Oh, well.
You can't do that.
We can do it.
No, I meant like you can't find.
Oh, I know. You can't find anything about that. I was thinking the 13 was the hypotenuse. It's not. So. Never. All right. So, what's the sign of this?
13 over the square root of 350.
Would you give us a problem with that?
Why not?
Why?
hurt anything.
Why would you do that?
It's just an ugly number. What about tan inverse of cosine of
Sine.
2 pi over 3?
I thought you have to have a ratio inside.
It's
Ah.
not.
Read it right. Tan inverse takes a ratio. Cosine takes a angle. That's right.
See, that might confuse me.
It's the closest one. Angle to cosine is the closest relationship. You don't go all the way up to tan inverse. All right, so what do I draw?
You draw a picture.
2 pi over 3. What quadrant?
Second,
Second, so it's over here.
Yep.
Problem.
cosine is negative over there.
Cosine is negative over there. Problem.
Tangent can't be in there.
Tangent can't be there.
It's first and fourth.
It's first and
So you have
fourth.
to go
So
first.
which one does it go in?
First quadrant. It's the first. It's a what?
Why would you do that to us?
If you're in the second quadrant, cosine is negative, but so is
Tangent.
tangent. So if you go over to these two quadrants, out of those two, which one is tangent negative?
Before.
The fourth. So the angle has to go down here. I'll give you a trick with tangent. It's always going to form a straight line. If you're in the second quadrant, tan inverse works directly opposite. If you're in the third quadrant, tan inverse works directly opposite.
Because tangent is always a straight line.
Well, in that case, yeah. Well, you could think of it that way. It's just off by pi. It's off by pi. So how do I label this? What is this angle?
No, that's pi over 3.
Pi over 3, sure. What's the answer here?
60 degrees.
I know that. It's pi over 3. So do I just write pi over 3?
No, negative pi over 3.
Negative pi over 3. Because you're going
You're going down.
down in that direction. That's
Going
negative.
Clockwise.
Clockwise is negative. Counterclockwise is positive.
Why do they do this?
Fine. Now I get to my last
I
one.
have a question.
Go for it.
You said that the inverse would have to be
In the first or the fourth?
with the answer. Can it be that?
We're gonna die.
Negative?
No, with the thing, with the,
Pi?
mhm.
Cosine of an angle is a
Ratio.
tan inverse of a ratio is a.
Oh, okay, I'm
Angle.
sorry.
That's what I'm saying. If you know what all the pieces are, you should know what kind of answers spit out of
Okay.
it. All right, last problems then. 2 of them.
Yeah.
What about cosine inverse of the sine of x? I think that's right.
No, it's not right at all.
You're right.
You
The
made a
inverse is
mistake.
in here.
Exactly.
So get rid of that inverse out there. I have to do that for the thing.
Yeah, yeah.
So cosine of sine inverse of x. I think that's right.
No, it's not right.
It is.
Never right.
It's always right.
Never right.
So how do I find it?
You draw a picture.
Where would I draw it?
Yeah, Ryan, where would you draw it?
And the first and fourth.
Actually, both of them, right? Because x could be
Positive or negative.
positive or negative. But for this argument's sake, let's just say it's in the first. If it's in the fourth, I'll show you that the answer is exactly the same. So if this is the angle theta, is x the angle?
We good.
Is it an angle or is it a ratio? You tell me.
It's an angle.
So sine inverse takes an angle,
No, it's a ratio.
takes a ratio.
Mhm.
So this x has to be a ratio. This is why I always want you to go back to what the heck is it?
Oh, it's a
Okay.
1 over
Well, it's x over
1. X.
1.
What is, wouldn't that put, if it's just x itself, would it still be
Okay.
just 1?
How do you write 2 as a fraction?
2 over 1.
2?
2 over 1.
2 over 1. You can't change the value. So you write that as x over 1. So if it's sine inverse of x over 1, where would you put the x in my picture? Opposite side. So here's x. Where would the 1 go? The hypotenuse. What's the third side?
Square root of 2.
No, you do Pythagorean theorem. C squared equals a squared plus b squared. What's c in this case?
1.
And 1 squared is? 1. What's a or b in this case?
It's x.
Alright, so x squared plus b squared. Don't know what b is. What do you have to solve for? B. So if I solve for b, I'm going to get b squared is equal to
1 minus x squared.
1 minus x squared. And therefore b is equal to?
The square root of 1 minus x.
I was wondering why you left the square off. Yeah, the square root of 1 minus x squared. Can you simplify that? Heck no, there's a minus sign in there. Now, technically, you're supposed to put plus or
Fine.
minus here, right? But whether you put the picture in the first quadrant or whether you put the picture in the fourth quadrant, it's always positive. Why? Why is it always the positive one? Where's the third side? It's right here.
Oh, okay.
Where is it always located?
So it's positive.
The positive x-axis. So it's guaranteed to be positive square root of 1 minus x squared, whether x is positive or negative. So what's the cosine of this angle now?
That's adjacent over hypotenuse, isn't it?
Yeah, so that would be,
Square root of 1 minus x squared.
and there's your answer. Well, over 1, but anything divided by 1 is itself. Ta-da! Isn't that cool?
No, it's not.
You try this one then.
Everybody in here fucking drew it.
Sine of tan inverse of x. Sine of tan inverse of x.
You can't do it.
Why?
I don't know.
It's the same thing as that.
But it
Thank you,
involves,
Ryan.
it involves inverse and tangent.
Huh?
I'm so confused.
Huh?
Okay. The thing you start with here is recognizing that x is a
Ratio.
ratio. It's inside a sine inverse. Put it in the first quadrant just to be safe. So you assume your sine is in the first quadrant, x is your ratio, and you're trying to find the function on the outside. So what do you do first?
Draw a picture.
Draw a picture. Where do I draw my triangle?
Inverse.
Put it in the first quadrant. Is x the angle or is it the ratio?
Ratio.
So this is theta. Where do I put x?
It's x over 1, so
Opposite over
Adjacent.
adjacent. So the x goes
It's right here.
here.
and 1 goes there.
What goes on the third side?
C squared.
Sure. But what exactly goes on the third side?
Square root of x plus 1.
Close, no cigar.
Square root of 1 plus x squared.
That's one way of writing it. This would become the square root of 1 plus x squared, or x squared plus 1. Either one works because addition is commutative. How do you find that? You go c squared equals a squared plus b squared. C in this case is the unknown. A is, well, he chose 1. B is,
X.
so you get x squared. And when you solve for c, you just square root both sides. When you get the square root of 1 plus x squared, or the square root of x squared plus 1. So my final answer up here is
Sine, which is opposite over hypotenuse, so x over square root of 1 plus x squared.
and there you go.
Can't reduce that at all.
No.
Okay.
You cannot simplify radicals with pluses in it. Unless it's a perfect square to begin with. Oh, I knew this chapter would be.
Ridiculous.
Well, people don't like going backwards. They like going forwards. But the cool thing with trigonometry is whether you're going forwards or backwards, you do the same thing. You draw a picture, you find out what quadrant you're in, you draw a little triangle, you label the information you have, and you see what spits out. And you use some old hippie fucking over hippie.